In this video, we'll be going over a past paper question. So the question that we have taken here is question 24 from the paper 2 calculator paper from Edexcel of the 2023 year. So this was the this was in the high paper, and this was the last question in the paper. So this is a question that tries to filter out your grade 8 and 9 students from the rest. This question is worth 5 marks. And it's great at bringing together the different rules that we know, like Pythagoras, expanding out our brackets, and also dealing with the area of shapes. So question 24. The diagram shows 8 identical regular octagons joined to enclose a shaded shape. Each octagon has sides of length A. Find in terms of A an expression for the area of the shaded shape. Give your answer in the form P times 2 plus root 2 times A squared, where P is an integer. You must show all your working. So for this question, we know that our area is going to be given in terms of A. So we don't have to do anything big to find out what the value of A actually is. We only have to focus on finding P and giving it in the format that they've asked for. So in the way that they've shown is P times 2 plus root 2 times A squared. So that's the form that we want to get it in. So we want to find our A squared, and we want to find a value of our coefficients of A squared that have the form of 2 plus root 2. So what we're going to do is, starting off, is we're going to actually draw a square in our shape. So we're going to isolate 4 triangles. Now the 4 triangles that we're isolating here, they are all isosceles right angle triangles. And we know that they're right angle triangles because if we take the internal angles of a regular octagon, as stated in the question, the internal angles of a regular octagon is 135 degrees. Multiply that by 2, you get 270 degrees, and if you subtract that from 360, you get 90 degrees. Our right angle triangle here is formed by our 90 degrees. So what we can start off with is we can start off by finding the area of our triangles. We're told that the sides of the octagon have the side length of A, so we can start off with that. So we can label our 2 sides A and A. So since our triangles here are right angle, our base value is A and our height is also A. So we can use our equation half times base times height. So for the area of our triangle, we can use half times base times height. We're given our base as A and our height as A. So we just have half times A, which is equal to A squared over 2. Now if we go around our shape, we have 4 of those triangles that we've isolated. So we just multiply our value of one triangle by 4 to get the area of our 4 triangles. This is just A squared over 2 times 4, which gives us with 2A squared. Now we can approach our square. So with one of the sides of our square, we can label our A values on both sides of our triangle, but then we're left with the area in red we used to isolate our other triangles. Now we have to find the length of this. What we can do is, we know our triangle is right angle, so we can use Pythagoras' theorem. Our A squared plus B squared equals c squared. So when we have our root of a squared plus a squared, we have our root of 2a squared, and we can isolate both terms. So we have root 2 times root of a squared, so we're left with a times root 2. And this is the length of that area, that length that we have. Now we have the length of one of the sides of our square. So by bringing all these values together, we have a plus a plus a plus a root 2. And this has a total of 2a plus a root 2. Now we can see here immediately that we're on the right tracks because our 2 plus root 2 is replicated in the value that we've got for one of the lengths of our square, and it's the same as what they're expecting of our answer. So we know that we're on generally the right track. However, we can't stop here. We have to find the area of our square now. And to do this, we're just going to have 2a plus a root 2 the whole squared. And we're just going to expand our brackets. So we have 2a the whole squared plus 2 times 2a times a root 2 plus a root 2 the whole squared. And now we're going to deal with each of our individual terms. So 2a the whole squared is 4a squared plus 2 times 2a is 4a. And if we multiply that with a root 2, we're left with 4 root 2a squared. So we have a, so we can write it in this form. And for our a root 2 the whole squared, we're left with 2a squared. Now we can bring our terms together. So our 4a squared and our 2a squared can be brought together. So we have 6a squared plus 4 root 2 a squared. Now from here we can factorize out our a squared. So we've got the a squared that we need, which is asked for in the answer. And we can factorize out our a squareds, or we can bring their coefficients together. But before we do that, we're going to add in our 2a squared from the area of our 4 triangles. So we're going to add our 2a squared with 6a squared and 4 root 2a squared. Now we can bring together our terms once again. So we're left with 8a squared plus 4 root 2a squared. So now this is the area of our shaded. This is the area of the shaded region. But we can't stop here. We still have to give it in the form that they require. So the first thing that we're going to do is we're going to factorize out our a squareds. That's what we know that we have to factorize out. So we have a squared times 8 plus 4 root 2. Now just for our ease, we're going to move the a squared value after the brackets. So it still gives the same answer, but we just have it in a different order. So we have 8 plus 4 root 2 times a squared. And this is also the form that they've given in the question that our answer is required to be in. Now we can factorize out our value of p. So what we can factorize out from our 8 plus 4 root 2 is 4. So we have 4 times 2 plus root 2 times a squared. And this is in the form of p times 2 plus root 2 times a squared. And so we know that the answer that we have is where p is an integer, and this is correct.
As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.